So you're a senior multi-cloud architect. You already know the pressure is on. You've got to keep your environments secure, agile, and totally consistent across every single cloud you touch. Let's dive into how you can escape that manual chaos and start managing your firewall rules the modern way, declaratively as code. Does this feel a little too familiar? You've got apps running on AWS, some on Azure, and others over in GCP. And you're the one trying to keep all those network security policies in sync. It's a high-stakes juggling act for sure, and you know one dropped ball can have some pretty serious consequences. That juggling act often feels less like a skill and more like being lost in a maze, right? Every cloud is its own language, its own logic, its own way of doing things, and trying to navigate all that complexity by hand, well, that's a huge part of the daily struggle for so many teams out there. Let's just be real for a second. The old manual approach is completely broken. It's painfully slow, because you're always waiting on tickets and manual changes. It's wildly inconsistent, because Bob might implement a policy one way and Sarah might do it slightly differently. And the scariest part? It is so risky. A single typo in an IP address, and boom, you've just opened up a critical vulnerability. And this is where the trouble starts. At first glance, this table seems pretty simple, right? AWS calls them security groups, Azure calls them network security groups, and GCP has its VPC firewall rules. Easy. But under the hood, each one has its own unique syntax, its own logic. Now imagine trying to manage those subtle, maddening differences across hundreds of VPCs and VNets. That's where the chaos really begins. So how in the world do we get out of this maze? Well, it starts with a shift in our thinking. We need to adopt a new blueprint, and that blueprint is all about treating our firewalls as code. This right here is the better way forward. And this is the core idea. It's actually pretty simple. With a declarative approach, you stop telling the system how to configure a rule. Instead, you just write a file that defines what you want the final result to be. You declare, hey, I want port 443 open to this specific IP range, and you let the automation figure out the nitty-gritty of how to make that happen on AWS, Azure, and GCP. And the difference is just night and day. We're moving from a world of typos and endless ticket queues to one where every single change is consistent and repeatable. Your security policies no longer live in a dozen different cloud consoles. They live in one single version-controlled place, your single source of truth. In auditing, it goes from being a nightmare to being trivial. You just look at the code history. Now, this isn't just some high-level theory. We have amazing tools that make this a reality right now. These are the workhorses that translate your beautifully written declarative code into actual cloud infrastructure. The heavy lifters in this space are tools like Terraform and its open-source fork, OpenTofu. The best way to think of them is like a universal translator for cloud security. You write your firewall rules just once in their language, and they handle all the specific, complex API calls to configure security groups in AWS, NSGs in Azure, and firewall rules in GCP. But here's a really important point. Tools are only half the story. The real magic happens when you integrate these tools into a modern, human-centric workflow that actually improves how your teams collaborate and who signs off on what. So what does this new workflow actually look like in practice? Well, an engineer defines a new rule in code. Then they submit it for peer validation, just like any other software change. Another engineer takes a look, gives it a thumbs up, and only after it gets that approval does an automated pipeline apply the change. See? It's controlled, it's visible, and it's just inherently safer. And this is the real cultural shift. You're taking security policy, which used to be this opaque, specialized task hidden in a corner, and you're making it a standard, totally transparent part of your normal development lifecycle. Suddenly, security becomes everyone's business, a real team sport. Okay, but what if somebody goes rogue? What if an engineer makes a manual change in the cloud console to fix something quick, breaking our source of truth? That's where drift detection becomes absolutely critical. It's constantly comparing your live environment to what the code says it should be. So if someone opens a port for a quick test and forgets to close it, drift detection spots that mismatch, alerts you immediately, and lets you fix it. You stay in control. So when you bring all of these pieces together, the declarative code, this modern workflow, and the safety net of drift detection, the transformation is it's profound. You finally move from a state of reactive chaos to one of proactive control. And the payoff is just immense. You get a single unified security policy across all your clouds. You practically eliminate misconfigurations. You deploy changes way faster and, more importantly, safer. And when the auditors show up, you've got a complete version-controlled history of every single firewall change ever made. It is an absolute game changer. And that really brings us to the final thought I want to leave you with. Once you've successfully turned your firewall rules into reliable, auditable code that's managed through this robust peer review process, what other parts of your infrastructure could use this same approach? This mindset shift, it opens up a whole new world of possibilities.